So students, we're here and back on some sometimes, always, and never. So we're going to start kind of reviewing all the centers of the triangles that we learned and their segments that form them. So perpendicular bisectors go through the midpoint of a line segment. Now this is always true. Why is this always true? In the term perpendicular bisector means it's cutting in half, so it goes through the midpoint. All right. Number two, the centroid is the same distance to each vertex of a triangle. This is never true. And if you need proof, it's all these relationships we've had up here about being 1/3 and 2/3 and the whole length, half and double, so on and so forth. Stuff we've been talking about in the last few videos of the guided notes. The end center is in the inside of a triangle. End center, inside. This is always true. This is a well-named shape or well-named center. And remember, end centers inscribe the triangle and are formed by angle bisectors. All right. The center of a circle that circumscribes a triangle is the same as the center of the circle that inscribes the same triangle. So it's saying that can the circumcenter and the end center be the same center? This can sometimes be true. Now it has to be a very specific triangle. It has to be an equilateral triangle. Equilateral. It's only true for that. All right. Most of the time it's not true, but it can sometimes be true. The medians are perpendicular to the opposite side of a triangle. As you can see up here, these medians, like here's a median. It's clearly not perpendicular, so it's not always true. It's sometimes true. And this answer is going to seem kind of familiar. It's only when it's an equilateral triangle. If you have an equilateral triangle, the segment that connects the angles to the opposite midpoint, those are medians. Those would actually be perpendicular bisectors as well. All right, the circumcenter is on the exterior and the centroid is on the interior of a triangle. This is sometimes true. Remember, circumcenters can be anywhere. They can be inside, outside, on the side. Centroid, I don't think I said this, they can only be on the inside of a triangle. That kind of makes sense. The centroid is a balancing point. You can't balance a triangle on a side of a triangle or even outside the triangle. A centroid always has to be inside the triangle. All right, in the last video, we're gonna bounce to the iBook and do that.